Hi guys, this is AS Chemistry, Concentration and Titration. Question 1. N2O4 is a poisonous gas. It can be disposed of safely by reaction with sodium hydroxide. The equation is given. What is the minimum volume of 0.5 mole per dm cube NaOH needed to dispose of 0.02 moles of N2O4? So according to the equation given, 1 mole of N2O4 reacts with 2 moles of NaOH. So if the moles of N2O4 is 0.02, that means the moles of NaOH would be 2 into 0.02, which would give us 0.04 moles of NaOH. Now we need to find out the volume. So the concentration given to us is 0.5 mole per dm cube. This means 0.5 moles are present in 1000 centimeter cube of the solution, and the moles that we have are 0.04 moles. So 0.04 moles will be present in what volume of the solution? So this can be calculated by dividing 0.04 by 0.5 and multiplying this ratio by 1000. This gives us a value of 80 centimeter cube. Therefore, option D is the correct option for this question. Question 2. A typical solid fertilizer for use with household plants and shrubs contains the elements nitrogen, phosphorus, and potassium in the ratio 15 grams, 30 grams, and 15 grams per 100 grams of fertilizer. The recommended usage of fertilizer is 14 grams of fertilizer per 5 dm cube of water. What is the concentration of nitrogen atoms in this solution? So, in this typical fertilizer, nitrogen is 15 grams in 100 grams. So 15 out of 100 grams is nitrogen. That means 15% of the fertilizer contains nitrogen. And the recommended usage of the fertilizer is 14 grams. So 15 out of 100 is nitrogen. Out of 14 grams, how much would be nitrogen? That would be 15 upon 100 into 14, giving us 2.1 grams of nitrogen in the given fertilizer. So now we know the mass of nitrogen. What we need to find out is the concentration of nitrogen atoms. So first we convert mass into moles, which would be 2.1 grams upon AR of nitrogen, which is 14. So this gives us 0.15 moles of nitrogen. Now 0.15 moles of nitrogen is present in 5 dm cube of the solution. So we need mole per dm cube. So how many moles would be present in 1 dm cube? So this would be 1 upon 5 into 0.15. This gives us a value of 0.03 mole per dm cube, making option A the correct option for this question. Question 3. A household bleach contains sodium chlorate 1 as its active ingredient. The concentration of NaClO in the bleach can be determined by reacting a known amount with aqueous hydrogen peroxide. The equations given. When 25 cm cube of bleach is treated with an excess of aqueous H2O2, 0.0350 moles of oxygen gas is given off. What is the concentration of NaClO in the bleach? So the molar ratio of NaClO is to oxygen is 1 is to 1. So if moles of oxygen is 0.0350, that means moles of NaClO will also be 0.0350. This way we have obtained the moles of NaClO in 25 cm cube of the bleach. So we need to find out the concentration in mole per dm cube. That means 0.0350 moles are present in 25 cm cube. How many moles would be present in 1000 cm cube of the bleach? So this can be calculated as 1000 divided by 25 multiplied by 0.0350. This gives us a value of 1.40 mole per dm cube, making option D the correct option for this Question. Question 4. 0.02 moles of aluminum is burnt in oxygen and the product is reacted with 2 mole per dm cube hydrochloric acid. What minimum volume of acid will be required for complete reaction? So, aluminum burning in oxygen produces Al2O3. Balancing this, we have 2 moles of aluminum and 3 upon 2 moles of oxygen. So, number of moles of aluminum is 0.02. So, moles of aluminum oxide according to the molar ratio 2 is to 1 would be 0.01 moles. So, now we know moles of aluminum oxide. The next part of this question says that the product Al2O3 will react with hydrochloric acid. So Al2O3 plus HCl. So this produces 2 moles of AlCl3. So in total, we need 6 moles of chlorine. So the molar ratio of HCl reacting with 1 mole of Al2O3 is 1 is to 6. Therefore, if moles of Al2O3 as taken from the previous equation is 0.01, moles of HCl would be 6 into 0.01, which will give us 0.06 moles of HCl. Now that we have moles of HCl, we can calculate the volume because concentration of 2 mole per dm cube has already been stated. So 2 moles are present in 1000 cm cube. 0.06 moles would be present in how many cm cube? So the calculation would be 0.06 divided by 2 multiplied by 1000, giving us a volume of 30 centimeter cube. Therefore, the correct option for this question is option C. Question 5. A washing powder contains sodium hydrogen carbonate NaHCO3 as one of the ingredients. In a titration, a solution containing 1 gram of washing powder requires 7.15 cm cube of 0.1 mole per dm cube sulfuric acid for complete reaction. The sodium hydrogen carbonate is the only ingredient that reacts with the acid. What is the percentage by mass of sodium hydrogen carbonate in the washing powder? So we have a concentration of 0.1 mole per dm cube of sulfuric acid and we have a volume of 7.15 cm cube. So the first thing we need to do is calculate the moles of acid that reacts. So for this 0.1 moles are present in 1000 cm cube. How many moles would be present in 7.15 cm cube? So this would be 7.15 upon 1000 into 0.1, giving us a value for moles equal to 0.000715. So these are moles of H2SO4. So next is equation for the reaction of H2SO4 with sodium hydrogen carbonate NaHCO3. So when these two react, they result in the formation of Na2SO4. So 2 moles of NaHCO3 are required plus 2 moles of CO2 and 2 moles of H2O are produced. So here the molar ratio for the reaction of sulfuric acid is to NaOH is 1 is to 2. So since the moles of H2SO4 are 0.000175, moles of NaHCO3 would be twice that of 0.000175. This gives us a value of 0.00143 moles of NaHCO3. Now that we have moles of NaHCO3, we need to calculate the mass. So in order to calculate the mass, we need MR of NaHCO3. So the given values for the AR of the different element gives us an MR value for NaHCO3 to be 84. So the next step would be to calculate the number of moles. actually to calculate the mass, which would be number of moles into mr, which is 0.00143 into 84. This gives us a mass of 0.12012 grams. So now that we have the mass of NaHCO3 present, we already have been provided the mass of washing powder, which is 1 gram. We need to find the percentage of NaHCO3 in the washing powder. So the calculation would be mass of NaCO3 present, which is 0.12012 upon mass of washing powder, which is 1 into 100 to obtain the percentage. This gives us a percentage value of 12.012%, making option C the correct option for this question. Question 6. A sample of potassium oxide is dissolved in 250 cm cube of distilled water. 25 cm cube of this solution is titrated against sulfuric acid of concentration 2 mol per dm cube. 15 cm cube of this sulfuric acid is needed for complete neutralization. Which mass of potassium oxide was originally dissolved in 250 cm cube of distilled water? So, we have the reaction that takes place originally is K2O plus H2O producing 2 moles of KOH. So this is how the solution turns basic. Now this basic solution reacts with H2SO4. So the next equation would be H2SO4 plus 2 moles of KOH producing K2SO4 as the salt and H2O, 2 moles of H2O as the other product. So this is the reaction for the neutralization of KOH. So now what we need to do is we have been provided with the volume of solution that is used against volume of acid that is required. So the first thing is to calculate moles of acid. So moles of acid would be 2 moles are present in 1000 cm cube because the concentration is 2 mole per dm cube. How many moles would be present in 15 cm cube? So step 1 would be 15 upon 1000 into 2, which would give us a mole value of 0.03 moles. Okay, so step 2. Now moles of H2SO4 are 0.03. Moles of KOH would be twice of that, which will give us 0.06 as moles of KOH. Now that we have moles of KOH, according to the first equation, if this is 0.06, then K2O is half of the moles of KOH. So half of 0.06 would be 0.03 moles of K2O. This way we have obtained moles of K2O. So now moles of K2O present in the solution that reacted are 0.03. Therefore, we have 0.03 moles present in 25 cm cube that reacted. How many moles would be present in the original solution, which is 250 cm cube? So this would be 250 upon 25 into 0.03, giving us a mole value of 0.3 moles of K2O present originally. So now we have moles of K2O present, and we can have the MR of K2O because the AR values are given. So the next step would be to calculate the MR of K2O. So MR of K2O would be 39.1 into 2 plus 16, giving us a value of 94.2. Finally, we have moles of K2O and MR of K2O. We need to calculate the mass. Mass is equal to moles into MR, which would be 0.3 into 94.2, giving us a value of 28.26 grams, making option B the correct option for this question. Question 7. The shell of a chicken's egg makes up 5% of the mass of an average egg. An average egg has a mass of 50 grams. Assume that the eggshell is pure calcium carbonate. How many complete chicken eggshells would be needed to neutralize 50 cm cube of 2 mole per dm cube ethanoic acid? Okay, so let's take this question step by step. First step would be to calculate the mass of the eggshell. So 5% means 5 out of 100 is the mass of an average egg shell. So 5 upon 100 into 50. 50 is the average mass of an egg. So this would give us a value of 2.5 grams. This is the mass of an eggshell. One egg shell mass. Okay. Next, assume that the eggshell is pure calcium carbonate, which is CaCO3. So MR of CaCO3 would be calculated to be 100.1. And next, how many complete chicken eggshells would be needed to neutralize 50 cm cube of 2 mole per dm cube ethanoic acid? So ethanoic acid is CH3COOH. So when calcium carbonate reacts with CH3COOH, the product formed are Ca bracket CH3COO minus taken twice, which means 2 moles of ethanoic acid are required, plus CO2 plus H2O. So the molar ratio for the reaction of calcium carbonate to ethanoic acid is 1 is to 2. So the moles of ethanoic acid that reacts are given the concentration 2 moles are present in 1000 cm cube. How many moles would be present in 50 cm cube? This would give us 50 upon 1000 into 2, giving us a mole ratio of 0.1 moles. So the moles of ethanoic acid is 0.1. We need the moles of calcium carbonate. So according to the equation, the molar ratio of ethanoic acid to calcium carbonate is 2 is to 1. So moles of CaCCOOH is 0.1. So moles of calcium carbonate will be half of 0.1, which will give us 0.05 moles. So now we have moles of calcium carbonate. Next, we need to calculate the mass of calcium carbonate. So mass is equal to moles into MR, which is equal to 0.05 taken from here. And MR we had already calculated as 100.1. So this gives us a mass value of 5.005 grams of calcium carbonate present. The question asks us how many complete chicken eggshells would be needed. So the mass of a single eggshell is 2.5 grams. The total mass of calcium carbonate is 5.005. So what we do is we divide 5.005 by 2.5, which gives us the number of eggshells as 2. Therefore, option B is the correct option for this question.